Good afternoon, I'm Mr. S. You're looking here at a very good video here, pre-calculus subject, advanced math subjects, high school mathematics, here on absolute value. Part 1 of 3 videos will talk and present with regards to this absolute value. The very first question is a bit of a comprehensive question. Discuss the absolute value function and its attributes. The absolute value function is very well f of x is equal to this right here, absolute value x. When you're looking at this, you're thinking about a graph which you should memorize in terms of its presentation. It looks like this. It is a function because it very clearly passes the vertical line test. So you have the vertical line test, VLT, and it passes that. It's a function by true means because it clearly passes that vertical line test. For each x-axis value, there'll always be a single y value, corresponding y value. Okay, so that's the two main attributes of the absolute value function that you should know of, and the graph looks something like this. It has a vertex here, especially when it's not translated at the origin. What are the additional important attributes you need to know? Well, it's this. The domain is always minus infinity to positive infinity. From left to right, it's going minus infinity to positive infinity. In terms of the range, you should know this. It goes no lower than 0, but it goes up towards infinity. 0 is included in the range, and it's 0 to infinity. Additional features you need to know. It's a continuous function. What does that mean? It means that if you were to trace this function or this curve with your finger or your marker across it, you'll never have to lift your finger. You can trace the function line without lifting your pen or your finger. There's no break in it. Another one, it is a decreasing function. What does that mean? It is a decreasing function. Well, it's decreasing from a certain point to a certain point. From minus infinity up to 0, it's decreasing, meaning it's going downwards in terms of your y values or your range. In terms of the output, your function decreases from minus infinity all the way up to 0 and including 0 because it's going downwards. But likewise, then your function is increasing. These are the attributes you need to know for the absolute value. It's increasing now from 0, including 0, but up to positive infinity. What does that mean? In terms of the output, your values will be going up in terms of the y-axis. You'll have positive values going upwards as you go along the curve. So these are the attributes you should be familiar with regards to this very important function. Our last question for this video is to graph or draw these two specific functions, and we will do so. We have the first one, absolute value of x, with a minus and then a plus 3. Let's do that first. You know you're looking here at an absolute value function which would generally be here starting from the origin, but we have a plus 3, which means it's directed 3 points above. If the origin originally was 0, 0, now because of this plus 3, it's been shifted upwards. Remember, you want to remember this form, x minus h plus k. X minus h is within your absolute value, and then you have a plus k. Here you can put a plus or minus to reflect any kind of reflection. Well, you're looking at a minus over here, so something which would have been pointing upwards would now be pointing downwards, and here would be your graph. And let this be the graph of A, which is right here, and this is graph of B, which I'll draw right there. So this right here is the graph of function minus absolute value of x plus 3, shifted up by 3 units, but reflecting down because of this minus sign. How about this? 2, absolute value x minus 3 plus 4. Well, this 2 over here represents very well a magnitude of an A. Let's look at that. A large value here greater than 2 means it's vertically stretched. Think back to that video I posted not too long ago about stretching and compressing. Anyhow, you start here with the vertex determination. Here it's 3, 4. H, k, 3, 4, because you're looking here at an x minus plus 3. You shifted 3 units to the right, and then you shifted 4 units to the top. And we're looking at like this, 3, 4. But then you're looking at a 2, and it's positive. It's going to be directed upwards. If something would be relatively not too stretched and not too compressed, well, the 2 will make it relatively stretched, vertically stretched, and it'll be compressed vertically, and that would be a good graph of that. Otherwise, a typical one with the coefficient here of A might look something like this, a bit more broad, a bit more horizontally stretched. Anyhow, this right here with the solid line would very well represent the graph of that. Vertex 3, 4, and stretched vertically, therefore horizontally it appears compressed. And that right there is the end of this video. Thank you for watching. Stay tuned. Have a nice day.